Hello, hello. Huh? Yes, yes. We are meeting for the first time. Second time. So this is second major topic for you. History, polity, economy, geography. These four will form 50% of the syllabus. There is no student who has not cleared the exam if he is comfortable with these four subjects. At some point of time, definitely you will be in the list if these four are good. If any one among this becomes weak, what happens is success postpones. The reason is until and unless, see for example, this polity is your easiest subject. Let's say economy is difficult. Unfortunately, in that year, polity became difficult. So we see many such evidences. So the point is, these four subjects either understand or by heart. At the end of the day, you have to be in the list. Okay. But the point is, as we will be available to any topic. If you don't understand, don't think something is basic. There is nothing called basics. Okay. Either I can explain you or I can't explain you. So ask anything that you don't feel comfortable. We'll try to help you out in the simplest way possible. There is no standard book available. Okay. For geography, there is no standard book. NCRTs are the standard books. My suggestion is, in the book, give me this one. All right. I want you to have line of this much. Okay. Write notes here. Write notes here. Exam, you will get 16 centimeter. 16 centimeter. Anything that you draw should be within that 16 centimeter. So, as of now, it's fine. In this side, I want you to write additional information. For example, you read NCRT, you read current affairs. You add in this particular point. PYQs. You go through PYQs. While studying PYQs, you found a question. You can write it here. So that this book will be reference for you forever. Okay. And in the notes, you can use blue, black, red. Geography has all colors. Okay. So that you can. But most importantly is when we see geography is associated with maps and diagrams. Okay. Remember this. If you have 10 marks question, 40% is given for diagrams. So let's say you wrote a 10-mark answer, right? You did not draw diagram. I have to give you only for 6 marks. I can't give for 10. Are you getting the point? So that means you are not giving me scope to give 4 marks at all. And I will draw India map something like this and mark. No, 4 marks. It's worth 4 marks. Okay? And see here, as of now, you draw bigger, but ultimately your India map should be this much. Okay, I told you this much you will get 16 centimeter. Ma'am would have told you these aspects, but telling you this much will be the space. 5 marks, one page will be given. 10 marks, two sides will be given. 15 marks, three sides. Okay, this side you should not write. This is for first evaluate. This is for second evaluate. Okay. So whenever they evaluate, first evaluator will do the check. He'll give 5 marks. Like that he will do everything and he'll write he got 90. Second evaluator will give 6 and all. He'll give 100. Okay. So average will be 95. So your score will be 95. Okay. So if one guy gave 90, another guy gave 120. Gap is more. Then they'll give it to third evaluator. Third person will evaluate. Third person will tell 110. Your score is 115. These two they'll take average. If he says 80, Okay. Why? Because remember, in my house, some problem is there. I came, I evaluated, I didn't give marks. Someone gave marks. That shouldn't affect the student's life. So it's more about what? Objectivity, not about what I feel or you feel. And second thing, remember, papers are not evaluated by subject specialist people. Never paper is evaluated by subject specialists. For example, you take first paper. You have history, society, geography. Who will evaluate the paper? The polity teacher. Like, so normally whoever evaluates the paper, they won't be knowing all the subjects, correct? So I can't judge his knowledge. I'm not judging his knowledge. He is there to judge others' knowledge. What I'll do, I'll give a model answer. Every question will be given a model answer. If I am giving the question, I have to give model answer also. And in the model answer, I will give points. Always, that is one of the reason many people tell write points, write points. The reason is I'll give points. And I'll be like 10 marks, 10 points. These 10 points are there, 10 marks you give. These 10 points are not there, 7 are there, give 7. So it's easy for the evaluator because remember, so many people will be evaluating. They don't want to complicate things. These 10 points are there, give marks. Not there, don't give marks. As simple as it is. Then you see what happens if you're writing in your mother tongue also, Telugu, Kannada. Some people write even mains in mother tongue. Who will evaluate? Same English and Hindi teachers only evaluate. What is the difference? There will be Hindi teachers evaluating, English teachers evaluating. There will be a translator. They'll call a translator. You come, like he will read the paper. He will translate. Let's say I will do in English. Some student has written in Bengali language. Okay. So Bengali translator will come. He will tell, sir, he has read this. I will see, acha fine. This point is there, I'll give one. So evaluation is done by either English or Hindi because you cannot go in search of all languages, all subject specialists. And most importantly, I can't translate answers in all the things and keep it ready. So I'll bring translators, get it done. Okay. So anything that you are doing, any exam for that matter, you should know the basics of the exam. How the evaluator is going to do. What is the merits? What are the demerits? What are you planning? So whenever you write any mains topic or anything, try to take keywords first. Okay. Keywords, without keywords, whatever you do, you might have read separation of power, something, right? Keywords. What are the 10 keywords that I want to do? Degree completed, everyone? Yes. In degree, what did you do? Last minute, do you read entire thing or keywords? Someone will tell keywords. You will remember, go and write. See, exam, however you study, your English will be good. Don't worry. Like, people will write because you all wrote your degrees and all in English only. UPSC mains is similar to degree. Evaluators are also same. But what is the difference? It's all about the vastness. So many subjects you have to do. That's where you forget. Today, if you will remember, but by the time it comes, you forget. Who will remember? The one who makes short notes. As of now, you keep big notes, but later you keep short notes, keywords. That helps you. Fine. I will tell you where prelims questions will come, where mains questions will come. And NCRTs, whatever books is given to you, and whatever books the shopkeepers are taking printout, they're not taking printouts of all the chapters properly. NCRT website, 11th standard NCRT at least, you see from the website because many tables are missing in this book that they are taking printouts. It's not institution's fault also, it's shopkeepers. When they take printouts, they are leaving, not publishers also, shopkeepers. They take printouts directly. They are only printing in Hyderabad. For UPSC is not doing anything or institution. So I'm just telling this 11th standard fundamentals of physical geography. That if you have, that's more than enough. Okay. And for every subject, you should have a micro schedule of the subject. Okay. What all are there in that? So now, when you take geography, geography is divided into physical geography. And don't do like, running notes. I'll explain and give you the time because we'll be changing a lot. I don't want you to keep scratching them. You see, physical geography is mountains, plateaus, plains. So for this plain world map, plain India maps, keep it with you. You should mark them in the maps directly. Keep whatever I show you. What you should do, let's say I'll tell you look at Nanda Devi. I'll tell you. Okay, you saw in Uttarakhand. Keep India map, you mark there, and here also you mark it as Nanda Devi and write there itself. Plain maps will help you to practice. Once you go back home also, you take plain maps and keep practicing the places. Because the moment I tell you some mountain name, rather than just remembering it, okay, I told you some mountain called Andes. It's in South America. You draw like this until Andes. So you'll always remember where it is present, which side it is present. Questions would be easier. See, you are not writing a small exam. This is not a small exam. You will have vast information, and all that information should be in pictorial form for you. Any subject, even polity or anything, articles you write, keep seeing what you wrote because that will be there in your mind clearly. You might have seen school days and all. When you read anything repeatedly, even now, some children, when they write answers, they write entire answer, they forget a word. They give gap there. And then they write all other words. They would have forgotten that. They go back, come, they don't get that word, they leave. So it's very important for you to remember like that for prelims. That image must be there. Anything. This page answer should be there. That's why for prelims, multiple revisions are important. Why? Because prelims is what? Question is also there only, answer is also there. You are not writing anything, correct? You are not recollecting anything. It's just like, have I seen this before? If you get that clarity, you are in. Okay. And no evaluator will create new sentence. Trust me, no one will create new sentence. What do they do? For the same sentence, they will add not. They will add only. They will add no. And your problem is you know you have seen the line, but whether not is there, all is there is the problem. That if you can work out, that's more than enough. See, physical geography is again divided into world physical geography, Indian physical geography. Human geography is also divided into world and India. Now, seventh standard NCRT is about world physical geography. Eighth NCRT is world human and economic geography. Okay. Nine, Indian physical geography. 10, Indian human and economic geography. 11th standard, two books are there. So 11th standard is about world physical geography, Indian physical geography. 12th standard, two books are there. Both are what? Human and economic geography of India and the world. So whenever you read world geography, that is world physical geography, 7th and 11th together you should read. For example, you are reading about atmosphere. You read in 7th standard also, you read in 11th standard also. Are you getting the point? Don't sit with one subject or one book and read. Both you complete. Additional points in the class notes you add. Every day, whatever we will be teaching, I'll tell you the page numbers or like, books, what you have to see. Go back and see that particular one. That's more than enough. Okay. So you write this. syllabus itself is divided in this form. This much, like, if we take, this is mostly for prelims. Here they catch mains. Okay, you got? Good. Now, we'll start class with climatology. Yes. World Physical Geography. Biogeography. See, guys, biogeography and environmental geography are part of geography itself. But in 2011, like, UPSC clubbed two exams. Okay, one was Forest Service, another IAS, IPS, and all. After that, environment actually increased. Questions on environment increased. So you will have separate environment and ecology classes. Here I'll give some basics of biogeography. Okay, now when we teach, I'll give you for each one what all we are covering. Climatology. So syllabus is very simple. Atmosphere, temperature, humidity and precipitation. You write down along with me. Atmosphere, temperature, humidity and precipitation, atmospheric circulation, winds, air masses, fronts, frontogenesis, cyclones, anticyclones, world climate. Okay, this is one of the lengthiest ones. Others are not so lengthy. It is technical. Okay, here less terms, but more of understanding. Geography looks factual, but we'll try to recollect now itself. There is nothing that you need to worry if you understand in a logical manner. Okay, it's a scientific subject. Okay, so done. Now, don't write. I'll give you some basics, then we'll see other ones. Atmospheric circulation. Now, guys, you see, I have two boxes, almost same size. In this box, I have more number of air particles. I have less number of air particles. Okay. Can you tell which one will have high pressure, which one will have low pressure? A will have high pressure, B will have low. Entire climatology, remember only this fact. What is it? Less number of air particles means low pressure. More number of air particles means high pressure. Whatever is the condition, anywhere if more air particles accumulate, it would lead to what? High pressure. Less number of particles are present, it is low pressure. And then when we say I have more, I have less. Okay. Can I say from that concept this is high pressure? This is, if I connect these two, goes from where to where? High pressure. Wind always blow from high pressure to low pressure. Okay. It never goes from low pressure to high pressure. And what is force? What is force? Force is anything that makes it to move. Okay. It should either move, it should increase the speed, it should decrease the speed, or it should stop. Anything which makes it to move, that is called as what? Force. Now here, do you have force? Is there movement? Yes, from where to where? High pressure to low pressure. Can I call it as what? Force. Okay. But the force is created because of difference in pressure. Do you agree? The force is created because of what? Difference in pressure. So that is called as what? Pressure. Now, here, can I say it's more? It is less. Do you have a slope? That is called as what? Gradient means slope. What is it? See, for example, if it is like this, anything will move from here to here. It won't go from here to here. So what is this called? This is called slope. Slope is called gradient. Now you tell, this is one slope, this is another slope. This is one slope, this is another slope. Can I call this steep slope? Gentle slope. Where will the speed be more? Steep slope, speed will be more. Gentle slope, speed will be less. Now use the same concept. I have 1000 particles. Yes. I have 800 particles. You see here, I have 900, I have 850. Okay, guys. Here you see, this is more, this is less. Steep. Here, gentle. Where speed will be more? Steep. So guys, now think and tell. When pressure difference is more, wind speed is more. When pressure difference is less, wind speed is less. Now, what is the meaning of pressure difference is more? So, whenever I say pressure difference is more, it indicates what? Steep slope. And what does steep slope indicates? Wind speed is more or less. In this case, pressure difference is less. That means what? Gentle slope. And gentle slope means what? Wind speed is less. You understand? This is the core of climatology. Okay. Wherever wind speed is more, they will normally go to, like, faster. They'll be faster. If wind, what do you call? If slope is gentle, it will be slow. These two. Now, let's say I have three boxes. You have three. Which is hottest? Coolest? 60. What is 80? No, no. 80, what do you call? No, no. I'm asking you, is it hot or is it cold? Mild, anything? Moderate? Good. Guys, 80 is cooler compared to 100. Okay? It is hotter compared to 60. So, nothing is hot or cold. Everything depends upon surrounding. Okay? Is 25 hot for you? It was 25. He told, sir, increase a bit. It's cold here. Germany, people are getting giddiness and they are falling down and they are dying at 25 degrees Celsius. So, what is it? Always relative. Hot or cold, high pressure, low pressure is not always same. It all depends upon what? Surroundings. So, if I take this is shortest till it comes, right? It is longest till this comes. So, it depends upon surroundings. Always remember these basics because suddenly something will be hot and with respect to something it becomes cold. Why? When you get confusion, it's all about what? Surroundings. Okay, you write down pressure, basics, you write climatology basics. You write pressure, heading pressure. I, in geography, in geography, especially in atmosphere, especially in atmosphere, density of air particles, density of air particles determine determine pressure. First, wherever there is high density of particles, high density of particles, it leads to high pressure, leads to high pressure. Underline that. High density of particles leads to high pressure. Similarly, low density of particles leads to low pressure. Draw these two. Leads. LEADs. Leads to low pressure. Draw in pencil. No, I'll give you. You write below. Next one. You write heading as pressure gradient force. Pressure gradient force. Below this, you write wind always blow from wind always blow from high pressure to low pressure. High pressure to low pressure along the gradient, along the gradient in brackets slope, known as known as pressure gradient force. Fine. Draw this. You write below gradient. The gradient is determined by next point. The gradient is determined by pressure difference. Pressure difference. Whenever pressure difference is more, comma, it indicates steep gradient, steep gradient, and and wind speed will be high. Full stop. Next point. If pressure difference is less, it indicates gentle slope and wind speed will be less. Draw these two. And wind speed will be less. box sizes should be same, at least closer. Okay, because volume should be same. In notes, don't write shortcuts. Okay, imagine 1 year down the line, you should understand what is PD. Pressure difference. Okay, good. Yes, at home when you practice, don't read lines. Lines doesn't make any sense. It's just English. Diagrams is important. Draw diagrams and revise. Because any language you can understand only on the basis of diagrams. Okay. Now, pressure and temperature. Okay. So now, particles are more, particles are less. This is what? High pressure. This is, can you tell which one will have high temperature, which one will have low temperature? What is this? Hmm, just think. In this classroom, okay, Telangana bus, after free bus services, okay, when you have more number of people in the bus, will you feel cold? What do you feel? Hot? Can I say if more people are there, what is going to happen? Temperature increase. High pressure normally leads to high temperature. Okay. And as particles reduces, number of particles reduces, it starts becoming cooler. Low pressure leads to low temperature. In physics, there is a concept, Boyle's law, which says PV is equal to R. V is volume, R is constant. P is directly proportional to T. That means what? High pressure leads to high temperature. Low pressure leads to low temperature. This is practically present only in few areas in atmosphere. In geography, it changes a bit. I'll come to that specific topic. But let's have, let's first apply common sense, then change according to the circumstances. Okay, what is it? High pressure, not high pressure. More number of particles leads to high pressure. High pressure leads to high temperature. Low density leads to low pressure leads to low temperature. Fine. Now, I want you to tell me, I want to increase temperature of this particular things. I have a box. I want to increase temperature. Okay. Can I say if I heat, temperature increases? This is external heating. I am giving heat from outside. That is called as what? Temperature increases. Put this case. I want to increase temperature without giving external heat. Can you help me? What can I do in this case? I don't want to heat it, but I want to increase the temperature. What should I do? Should I bring the particles closer or should I expand it? Should I compress it or expand it? Compress. So can we say compression leads to what? In heating, correct? Second question, can I say if I add more particles, I won't compress, I will keep it, but I will keep on adding more particles. You tell me if more particles are added, will it increase the temperature? Yes. Now can I say, here I am providing external heat. Here I am not providing external heat, either I am adding more particles or I am compressing. Either due to compression or adding particles, can we say temperature increases? Guys, anywhere if temperature increases not because of external heat, then it is called as adiabatic heating. Have you heard of this term? Adiabatic. What is the meaning of adiabatic? Without providing external heat, if temperature increases, it is called as what? Adiabatic heating. Now, by providing heat, if temperature increases, that is external heating. If I cool without providing external cooling, then it is called as what? Adiabatic cooling. I have two words. What are the two words? Adiabatic heating, adiabatic cooling. What is adiabatic heating? Increasing the temperature. How can I do it? Either through compression or by adding particles. Can you help me how to cool it? No, I have particles. How to cool it? One is through what? Expansion. Another one is through what? Removal of particles. Do you agree? Expansion or removal lead to what? Cooling. Addition or compression leads to what? Heating. Very good. Now you tell me, Earth, okay, closer to Earth, I have more number of air particles. Okay, closer to Earth, I have more number of air particles. As I keep going up, number of particles keep on reducing. More here, less here. Everyone tell me A and B. I'll divide it into two layers. Okay. Can you tell now which one have high density? A. A has high density. High density leads to high temperature. High temperature leads to high pressure. Here, low density, low pressure, low temperature. Very good. Now, you tell me this particular part. Observe this. Here, air is going above. Okay, guys? Air is going above. If air goes above, you tell me here do you have more place? If you have more place, will it expand or will it contract? Expand. So what is going to happen if it goes above? What is going to happen? There will be expansion. The moment there is expansion, will there be adiabatic cooling or adiabatic heating? Adiabatic cooling. So you will have what? Adiabatic cooling. Now you think and tell, water vapor has to become clouds. Water vapor has to become water. Is it condensation or evaporation? Condensation. Water vapor, if it cools, it will become what? Water. That means what? Condensation. Condensation means, should air rise? Yes. Rising air leads to adiabatic cooling. Ascending air. You see now same aspect. Is air coming down? If air comes down, can I say here number of particles increases? As number of particles increases, what is going to happen? In this part there will be compression. Compression leads to what? Adiabatic heating. This is another core concept where we say in atmosphere, wherever air rises, air expands. If air expands, it will cool. The moment it cools, clouds will be formed. Clouds will give rain. Are you getting the point? And if air comes down, there is no cooling. It leads to what? Adiabatic heating. And there is no rainfall. Deserts, air comes down. Evergreen forest, air rises. So if I know where air rises, I will get more rainfall. Where air comes down, I'll get less rainfall. Now you tell here, I have a mountain. Okay. Here air hits and rises. Here air descends. Can you tell which side is adiabatic cooling and which side is adiabatic heating? A is adiabatic cooling. B is adiabatic heating. Where will you have clouds? A. A will have clouds. B will have less rainfall. Here more rainfall. Here less rainfall. Where will you have forest? A. Where will you have deserts, grasslands? B. Are you getting the point? So you talk about Kerala, Tamil Nadu. Okay, Tamil Nadu, Coimbatore is there. On the other side, Kerala, Wayanad and other regions are there. So if you take like this, there will be mountains. Okay, wind blows like this. 1 and 2. Can I say 1 wind rises? Kerala gets very heavy. Coimbatore, no rainfall. Goa floods. Telangana less. Nowadays, Telangana also floods, but that's different case. You get wind. This is windward. This is leeward. But what I want you to know the concept. I'll come to those. What are the words? Adiabatic cooling, adiabatic heating. Anywhere in question paper, books or anything, they'll ask very simple thing. Due to adiabatic cooling, clouds are formed. This is a line they give. Okay, near the mountains, due to adiabatic cooling, clouds will be formed. They don't elaborate anywhere. You should have comfortable clarity that adiabatic cooling means from outside heat is not provided. Okay, it's purely about what? Expansion. Rising and expansion. Descending leads to what? Compression. So what is this called? What is this word? What is happening here? Rising. This is rising air. Here, descending. Descending air. Rising air, descending. Okay, you write below pressure and temperature. Pressure and temperature. No, I'll tell you. Pressure and temperature. Below that you write. Whenever density is more, there will be high pressure there will be high pressure and high temperature. Similarly, low density leads to low pressure and low temperature. So, so in atmosphere, in atmosphere, when when volume is constant, volume is constant, pressure is pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Draw this. You write below adiabatic heating and cooling. Adiabatic heating and cooling. Hyphen below this. Whenever, whenever air particles are compressed, air particles are compressed, it would lead to adiabatic heating. Adiabatic heating. First, whenever density of particles are increased, density of particles are increased, without providing, without providing external heat, then it is adiabatic heating. Next point, whenever whenever air particles expand, underline expand here, underline compression there, expand, it leads to Adiabatic cooling. When particles are removed, when particles are removed, then as density reduces, it leads to adiabatic cooling. Next, in atmosphere, comma, with increase in height, with increase in height, density reduces, density reduces. Due to this, due to this, as air rises, as air rises, there will be, there will be expansion and adiabatic cooling, and adiabatic cooling. First, wherever air descends, next point, next paragraph. Wherever air descends, it leads to adiabatic heating. As air compresses. Now this. shape should be like this, because expansion and compression. Yes. You understand the meanings? Hmm? Below you. There are there are two types of pressure. Two types of pressure. Hyphen first one, low pressure. So from all this, what you understood, what is low pressure area? Low density of particles leads to low pressure. Okay. Now I have two conditions. Everyone see here. Earth's surface, Earth's surface, and I told you, I hope you understand, relative. That is, high pressure and low pressure is relative to the surrounding. Now I have particles. Yes, more particles are there. You see, because of sun's rays, because of sun's rays, let me assume that this particular area is hot. Okay, that means what? High temperature. The moment land is hot, air above the land will also become hot. So whatever is in contact with will become hot. Hot air expands, rises. Balloon you might have seen, air balloon. Like it will be there. If you keep heating, it keeps rising. So what happens in this particular part? All the particles that are there will start rising. Correct? Now I want you to tell me, in this area, will you have more air particles or less air particles? Here. See, all the particles got heated. And what happened to hot air? Rised. If all the air rises above, here what is going to happen? Less number of particles. Now you tell, if you have less number of particles, is it low pressure or high pressure? Low pressure. So what is going to happen in this part? Low pressure. High temperature near the land. I'm not talking about atmospheric temperature. What am I talking about? Land temperature. The moment land became hot, air above the land also became hot. Hot air, what will happen? Rises. The moment hot air rises, in the ground, there will be less number of particles. As you have less number of particles, it's called as what? Low pressure. Now you tell me, surrounding region. Surrounding region, I have more number of particles, correct? Compared to this, I have more number of particles. You tell me more number means high pressure. Wind always blow from where to where? High pressure to low pressure. That means everything will come towards this low pressure area, correct? The moment it comes, imagine land is still hot. If land is not hot, what is going to happen? Everything will come normal. But if land is still hot, what is going to happen? Again, air gets heated. And what will happen to hot air? Rises. So can I say air comes, gets heated and rises. Air comes, gets heated, rises. Air is coming, converging air. What is it called? Converging air. And air is rising. So what are the two things happening? Converging and rising. Anywhere in atmosphere, if there is converging and rising, we call it as low pressure area. What is a low pressure area? What will you see in a low pressure area? Converging and rising. Now you tell me, rising air expands. Rising air expands. As air expands, adiabatic cooling or adiabatic heating. That means what? Low pressure normally leads to cloud formation. Are you getting the point? Why can you explain me what is the reason? Why is low pressure leading to cloud formation? Low pressure means what? Converging and rising. The moment air rises, adiabatic cooling. Adiabatic cooling leads to what? Cloud formation. It leaves rainfall. Why Hyderabad gets rainfall in the evening? Okay. Why? Because Hyderabad will be hot in the morning. If it is hot, if it is hot, can I say air compresses, converges, and converging and rises? So let us say there is a cloud. There is a cloud. What is happening? Air is converging and rising. Air rises. The moment air rises, particles hit and they give rainfall. Have you seen thunderstorms, lightning, everything occurs? Near equator, let's say, near equator. Can I say there will be high temperature near equator? Yes, because sun's rays is more. If you have high temperature, will air rise? Yes. If air rises, you tell me, will it form clouds? Yes. By 12 o'clock, very high temperature. 2 to 3 o'clock, clouds will be formed. Exactly 4 o'clock, rainfall will come. It's called 4 o'clock rainfall. 4 o'clock rainfall. Which region? Equatorial region. Every day at 4 o'clock, you get rainfall. Okay, and remember, all our religions try to use geography more. All religions use geography more. For example, Rajasthan desert is there. Okay, Rajasthan desert is like this. There is a mountain called Araval. Right? So here what happens? Clouds will go and hit. Here no rainfall, here no rainfall. But I told you whenever it hits, rises, adiabatic cooling. Here rainfall comes. Only here rainfall comes. Nowhere rainfall will be there. People saw. They went and built temple and told, see, temple is there, rainfall is there. Sri Lanka is closer to equator. Sri Lanka is closer to equator. Now they Buddha's tooth. Buddha's tooth they took and they went to Sri Lanka and they wanted to spread Buddhism. And what they did in Sri Lanka, they built a temple exactly at the center. You might have heard Araku Valley. Like that, you have some mountainous region. They built a temple there. And what they used to do, they used to go and see outside. And remember, clouds will give rainfall when it becomes dark. When it is in white color, it won't. We'll see why and all. So they see whether the cloud is dark or not. And they used to come and tell, sir, it's become dark. So they used to go, take the plate, teeth and all, go and show to the sky and come back. What will happen? Rainfall will come. Everyone used to feel, wow, see, rain is coming. Chinese traveler came. He also saw, wow, rain is coming. 1 week he saw. He went to China and told, in Sri Lanka, there is a tooth of Buddha. If we take the tooth, we'll get rainfall. They came, they captured the tooth and went to China. In China, China is away from equator. They went to desert, Gobi desert area. They went. Huh. Every day they started showing tooth. Will you get rainfall? No rainfall. They took some Buddhists also. You also come, let's do. Because remember, over ages, you don't understand the aspects. Everything is associated with some or the other geographical phenomena. And Indian systems are mostly geographical systems. I think we are discussing the other day. Uh, Why did you had, what do you call it as, Mahakumbh Mela? Mahakumbh. Yeah. So what was the reason? Yes. Tell. Jupiter made 12 revolutions. Very good. Sun. Yeah. See, basically, uh, Jupiter takes 12 years to complete. So it's Ardha Kumbh on the basis of the movement. Why Jupiter? Saturn also goes. Why don't you celebrate Shani Dasha? Have you heard? 7.5 years. That is what? One round. That is also one round. That also we consider. But here, what happens? Jupiter holds meteoroids, asteroids. Okay, just beside Jupiter, asteroids are there. Okay, asteroids. And these asteroids, if Jupiter is not there, they will go towards Sun. From Jupiter, they'll go towards Sun. So you have Jupiter here, you have asteroids here, you'll have Sun here. And if Jupiter is not there, all this will come towards Sun. Earth. You might have heard dinosaurs got extinct because of meteor attack. No one knows why all dinosaurs were there at that one place when meteor came and hit. Right? But we say meteor is one of the major impacts. The point is, so Jupiter is helping Earth and other planets. So as a respect, we do this. Okay. And 144, almost at that time, all planets will align. That is called syzygy. Syzygy. SYZYG. Now, what UPSC or any exam does, any exam is on the basis of these aspects. They don't ask questions about religion. You're an officer, you'll go there. It's your duty to conduct everything. But at the same time, you should know what is the rationality behind. Questions will be asked on the concepts, not on, like, the religious beliefs. Now, you got this. So, what is it? Wherever you have, right, converging and rising, it leads to what? Low pressure. I'll give you another one. See, I have a surface. From one side, hot air comes. Cold air. One side hot air is coming, another side cold air is coming. Whenever hot and cold air converges, which is heavier? Cold is heavy. Which is lighter? Hot air. Which one rises? Hot air rises. So, you see here, is air converging? Here also converging? Yes. So, what is going to happen? Cold air will be present here only, whereas which air rises? Hot air rises. Guys, you tell me now. Here more number of particles are there. Particles have started rising slowly. If particles rise, you tell me, will you have more particles here or less particles? Less particles. The moment you have less particles, what do we call it as? Low pressure. And can you tell here also what is happening? Can you see convergence? So here also what are the two phenomena? Converging and rising. So wherever I see converging and rising, I call it as what? Low pressure area. But there are two types. One, low pressure is formed because of, like, high temperature surface. This is not formed because of air converging. It is formed because of what? Temperature. So it is called as thermally induced low pressure. What is it? Thermally induced. What is the meaning of induced? Because of high temperature, there is low pressure. Are you getting the point? Low pressure doesn't lead to high temperature. I did not tell you anywhere low pressure is leading to high temperature. What am I telling you? High temperature leads to low pressure. Remember these lines carefully. If I say all men are good, okay, or all men are women, you might have seen syllogism lines. All men are women. Doesn't mean all women are men. Are you getting the point? It's always one. So that clarity you should have. What is this called? Thermally induced. And if you have, here you tell, is the air rising because of surface temperature or is it rising due to convergence? Convergence. So whenever it rises due to convergence and not due to surface temperature, then it is called as dynamically induced. Dynamically induced low pressure. So we have two types of low pressure. First, what is a low pressure area? Where no high temperature, nothing should come to your mind. Less number of particles. Why do you have less number of particles? There is converging and rising air. Anywhere they ask you, okay, Tibetan low pressure, what do you observe? They'll ask. Like, Tibetan low pressure, equatorial low pressure, somewhere, like, near North America, low pressure is observed. What do you observe? What is the meaning of that? There will be converging and rising. Second, there are two types. What is one? One is thermally induced. What is the meaning of thermally induced? High temperature leads to low pressure. What is dynamically induced? Whenever there is convergence of only warm air or warm and cold air. Warm and cold. You think now. Only warm air is there. Two are warm air. Both will mix. Two are cold air, both will mix, right? One warm and one cold. Then which one will rise? Warm air rises. Do you get this? So this is very, very important. Fine. You write below low pressure. Hyphen. It is an area. It is an area where there is converging, converging and rising air. Rising, rising air. It normally leads to low density of particles, low density of particles closer to the earth, closer to the earth. Draw this case. You write below. There are two types of low pressure. First one, thermally induced low pressure area. Right below. Whenever Earth's surface is hot, air above the Earth's surface air above the Earth's surface is also hot, and hot air rises. Full stop. As hot air rises, number of air particles reduces, and it leads to low pressure. And it leads to low pressure compared to compared to surrounding regions. Surrounding regions. First, in surrounding areas, in surrounding areas, there will be there will be high pressure. There will be high pressure, and air converges from high pressure to low pressure. High pressure to low pressure. First, as air converges, it would be heated, it would be heated and it would rise again, and it would rise again. This leads to this leads to continuous converging and rising air, leading to low pressure area, leading to low pressure area. This is formed due to high temperature near the high temperature near the Earth's surface, So it is thermally induced. Draw this case. Right. Right. Dynamically induced low pressure. Dynamically induced low pressure. Like, irrespective of irrespective of earth surface temperature, earth surface temperature, if there is low pressure, if there is low pressure due to due to convergence between warm air and cold air, then it is dynamically induced. First, whenever whenever warm air and cold air converges converges in opposite direction, in opposite direction, and as cold air is denser, cold air is denser, it would be it would be near the ground. Cold air is denser, it would be near the ground, and warm air rises, leading to low pressure area. low pressure area. Draw these two. Now, are you understanding the concepts, terms? Now, see this. We have air particles. Let's say here we have 900, 9. Okay. Now, land became cold. Land became cold. As land becomes cold, what is going to happen? Air will also become cold. And is cold air heavier? Yes, cold air is heavier. What is going to happen? Cold air will start coming down. So you will have cold air and all the cold air will start coming down. If it comes down, can I say these 1000, like 900 will become 1000? Because all the particles are coming down. As they come down, number of particles increases. As particle increases, it becomes what? High pressure. So what is going to happen? In this case, I will have what? High pressure. 1000 is high pressure and 900 will be low pressure. Wind will blow from where to where? High pressure to low pressure. That means from 1000 to now you please tell me what is the case here? This is called as what? Descending. What is this? Descending. What is this? Diverging. What are the two words of low pressure area? Converging and rising. What is the two words of high pressure area? Descending and diverging. Anywhere if you have descending and diverging, we call it as what? High pressure area. And you know that descending leads to adiabatic heating, doesn't lead to adiabatic cooling. So no clouds, deserts will be formed. If it is at Sahara Desert, if it is at what you call Indian Thar Desert, at that time it is hot deserts. Near poles, it will be cold desert. So, what is this? Do you understand? What are the two words associated with high pressure? Descending and diverging. Now you tell, is it descending because land is cooler? Yes. Cold surface. Whenever earth is cold and if it leads to high pressure, what is it called? Thermally induced high pressure. Are you getting the point? What are the two words? Thermally induced, dynamically induced. Now you see this. We have a surface and surface is not cold. Okay. Surface is not cold. Air above the surface became cold. Somewhere above, you have cold air. Due to some reason, air became cold. Now you tell if air is cold air heavier? Yes. What will happen? Starts coming down. After coming down, what is going to happen? It would die. Now you tell, is air coming down because air is cooler, or is air coming down because land is cool? Air is cool. So whenever air is cooler and if it comes down, we call it as dynamically induced. Okay, if earth surface is hot or cold and if it comes down or goes up, it is called as what? Thermally induced. Okay, what is this called? Dynamically induced. Can you write? High pressure. High pressure. Hyphen. Whenever, whenever there is descending air, then the number of air particles, high pressure. Whenever there is descending air, then the number of air particles increases leading to high pressure area. From the high pressure area, air will be air diverging from the high pressure area. From the high pressure area, there will be air diverging outwards. Outwards. So we normally observe descending and diverging air near high pressure area. Draw this. You write below, there are two types of high pressure. Two types of high pressure. First one, thermally induced high pressure. Induced high pressure. Whenever Earth surface is cooler, Earth surface is cooler, comma, air would become cooler, air would become cooler, and cold air is heavier. Cold air is heavier. Due to this, cold air would descend, cold air would descend, and it would diverge. Diverge, leading to this, leading to high pressure area. Draw this high pressure area. You should show diverging. Okay. Yes. Cold surface is different from diverging. You write below, dynamically induced high pressure. Yes. Dynamically induced high pressure. Irrespective of, irrespective of Earth's surface temperature, Earth's surface temperature, if air becomes cooler, if air becomes cooler and cold air would descend, would descend and it would diverge. Sorry. And it would diverge. This is dynamically induced high pressure. Draw this. Okay. So, yeah. See this, what we saw, more density of particles leads to high pressure, low density of particles leads to low pressure, and wind always blow from where to where? High pressure to low pressure. That is called as what? Pressure gradient force. Gradient is of two types: steep gradient, gentle gradient. Whenever difference is more, we call it as what? Steep gradient. When difference is less, we call it as what? Gentle gradient. And then, yeah, high pressure or more density leads to high temperature, low density leads to low temperature. Pressure is directly proportional to temperature normally. But we saw that high temperature, not in the air, land. High temperature land leads to low pressure. Low temperature land leads to high pressure. Yeah. We saw something called as adiabatic heating and adiabatic cooling. What is adiabatic heating? Whenever there is compression, it leads to adiabatic heating. Expansion leads to what? Adiabatic cooling. Huh. Wherever air rises, what will you have? Cooling, cooling or heating. Wherever air rises, there will be what? Expansion. Expansion leads to what? Cooling. And wherever air comes down, what you will have? Heating. Adiabatic heating. And then low pressure means converging air and rising air. I have two types of low pressures: thermally induced, dynamically induced. When will I have thermally induced? Whenever Earth's surface temperature is more. What will you have? Thermally induced low pressure. Whenever warm air and cold air meets, which air rises? Warm air rises. And converging and rising of warm air, irrespective of Earth's surface temperature, is called as what? Dynamically induced low pressure. Okay, we have two cyclones. Cyclone is a low pressure area. I have tropical cyclone, I have temperate cyclone. Tropical cyclone is thermally induced. Temperate cyclone is dynamically induced. So we will be talking like those terms. Okay. Then what is high pressure area? What are the terms that are associated with high pressure? Descending and diverging. Wherever you have descending and diverging, we call it as what? High pressure. And there are two types of high pressure: thermally induced, dynamically induced. Wherever land is cold, air above the land will be cold. Cold air descends and diverges. Do you recollect poles? Poles will have glaciers. Are glaciers cold? Air above it will be cold. It leads to high pressure area, tundra, polar region, cold desert we call. And when we talk about India and other parts, deserts, Thar desert and all, there you will have dynamically induced high pressure areas. What is dynamically induced high pressure area? Air becomes cooler above and it comes down irrespective of Earth's surface temperature. That is called as what? Dynamically induced. Okay, is this clear? Okay. All these are basics, guys. You won't have it in the NCRTs. NCRTs just uses them as passing reference. Okay, we will be reading them later in the books. Just practice it. Okay, we'll meet tomorrow.